Now let's consider a slightly more complex source where we have two sinusoids instead of one. One sinusoid is at my defined frequency of f0, which is 1,000, and the second one is at twice that value. So you see we have one at 1,000 and one at 2,000 hertz right now. Here I'm adjusting the scale to turn off auto scaling so we can stabilize that display. And at really low modulation frequency, this would be kind of like a very low frequency sort of tremolo effect right now. Let's try raising the modulation frequency a bit. And once we get above 20 hertz or so, then we start to get more of the AM type effect. So in time, the signal looks somewhat complicated. Let's also consider what it looks like in frequency. Right now I'm manipulating my signal frequency. Kind of check out this effect on the upper end. See how it appears to bounce off the top end? That's aliasing showing up right there. So when we would be causing the signal to exceed our folding frequency, it actually gets folded back into what we call the principal alias. So that's aliasing at the top end. I'm going to try putting in some specific numbers now for the modulation frequency. At this point, we discern two distinct sounds. That still sounds like several distinct pitches. And we can see that the spacing between the spectral components is not uniform, so they do not fuse into a single perceptible pitch. Now that sounds like pretty much a single note. And that sounds less of a distinct note there. Rest the ears a moment. Here's an interesting one that also sounds like a distinct pitch, and this would actually correspond to having every other harmonic being dropped out, and we do have a very strong middle harmonic. Now when we're slightly off from that number, this is where we start getting a beating effect as those two spectral components become very, very close to each other, but yet they're still different. And at exactly the right frequency, those two spectral components overlap, and that's why we see the middle ones are standing up there twice as tall as their neighbors. Again, we perceive this as a single pitch, again because of the fact that the harmonics are lined up according to integer multiples of the fundamental.